I was sitting in a dim research lab recently, watching a volunteer who had never set foot in a jungle or opened a primatology textbook. We were looking at grainy footage of a chimpanzee in Uganda, a large male who made a sudden, sharp flick of his hand toward a younger chimp. The volunteer didn't even blink. "He's telling him to get lost," she said, almost dismissively, and she was right. We played another clip, this time of a bonobo, an animal she'd likely never seen before, performing a strange, rhythmic rolling motion with its arms. "That's an invitation to play," she noted instantly. "It was fascinating to watch. This woman wasn't an expert. She was just a regular person off the street." Yet, like hundreds of others in the study, she was decoding the complex social gestures of our great ape cousins with over 50% accuracy, relying on nothing but raw instinct. There is a certain irony to it that the lead researchers even joke about. Imagine spending decades of your life braving muddy forests and meticulously cataloging thousands of hours of video to decode a language, only to realize that most humans can basically read a monkey's mind the moment they see one. We share roughly 95% of our gestural vocabulary with these creatures, a lost language we didn't even realize we still spoke. But it leaves you with a deeply unsettling question. If we can intuitively understand the subtle hand flicks and facial twitches of a different species living in the treetops, why is it that we still find it so incredibly difficult to understand the person sitting right across the dinner table from us? It turns out getting along with a human might be the real evolutionary challenge.
You know, the sheer magnitude of that shared gestural vocabulary, it just completely dismantles the traditional timeline of human evolution.
Yeah.
I mean, that's the stuff that has been taught in biology classrooms for generations.
Right, the whole neat and tidy textbook version.
Exactly. For a very long time, the prevailing assumption, this neat narrative we told ourselves, was that human language was this sudden, miraculous genetic leap.
Like a lightning bolt or something.
Yeah, a biological lightning bolt. Something that struck the hominid lineage relatively recently and just instantly, permanently separated our species from the rest of the animal kingdom. But the reality staring us in the face through this research is that the fundamental capacity for intentional communication did not just spontaneously generate out of thin air.
It's much, much older.
It is an ancient, deeply embedded physiological and cognitive trait that we share across all great apes. And look, when we talk about intentional communication, we aren't just talking about mere noise or an involuntary reaction.
Right.
We're talking about a highly specific, multi-layered cognitive mechanism. It requires the sender to use a signal directed at a specific recipient to achieve a very specific goal.
Okay, so targeted.
Highly targeted.
Yeah.
And it requires the sender to pause, wait for a response, and most importantly, it requires them to persist or even change their tactical approach if they realize they've been misunderstood.
So there's a feedback loop happening.
That behavioral loop is the absolute bedrock of what we consider language. And the data shows it was laid down millions of years before the first human word was ever spoken.
I think we really need to draw a hard line right here between, just making a sound and actually engaging in that intentional communication.
Absolutely.
Because it is incredibly easy for anyone listening to just assume that an animal growling or bird singing is talking. But there's this massive evolutionary gap between an involuntary reflex and a deliberate transmission of meaning.
It's a huge distinction.
Right. So think about your own physical reactions. If you accidentally touch a blistering hot stove, you're going to violently yank your hand back and probably let out a loud yelp of pain.
Sure, yeah.
Now, if someone else is in the kitchen with you, they hear that yelp and they receive information. They understand instantly that you are in pain and that the stove is a hazard, but you didn't yelp at them.
You weren't trying to send them a message.
Exactly. You were just broadcasting your internal physical state involuntarily to the room. That's non-intentional broadcasting.
Yep.
But take that same scenario and change the mechanics.
Sense.
You walk into the kitchen, you see someone about to touch that same hot stove, and you point directly at the burner. You look them square in the eye, and you shake your head sharply. In that moment, you are engaging in intentional meaning-making. You have a specific goal in your mind, keeping them from burning their hand, and you are directing a physical signal right at them to achieve it.
And waiting for them to stop.
Waiting to see if they pull their hand back. That is true intentionality.
And that directed, goal-oriented signaling was heavily fenced off by early linguists and anthropologists as an exclusive feature of the human mind. The assumption was that animals were merely biological machines reacting to stimuli.
Just yelping at the hot stove, basically.
Exactly. But this deep dive into the massive Scottish studies, specifically the really comprehensive research initiatives coming out of the University of St. Andrews, methodically dismantled that fence.
And they didn't just look at a couple of captive animals.
No, they didn't just observe a few apes in a zoo. They designed an enormous, statistically rigorous online playback experiment to test the exact boundary of human comprehension regarding these signals.
The scale of it is actually pretty wild.
To give you a sense of it, out of more than 17,000 people who initially engaged with this interactive framework, researchers carefully filtered and analyzed the raw data from a core group of 5,656 participants.
Over 5,000 people. That's a serious sample size.
Yes. And the methodology here is critical to understand because they had to strip away all the environmental noise that usually helps us guess what is happening in a social situation.
They had to isolate the raw data.
Right. So participants watched 20 short videos of 10 common chimpanzee and bonobo gestures. But crucially, the footage was surgically cut to remove any preceding or following behaviors.
Wow. So no context at all.
If a chimpanzee was gesturing for food, you didn't see the food in the frame. If a bonobo was gesturing to initiate play, you didn't see the play session that followed. You were completely denied the context. You only saw the isolated movement of the animal.
Which, I mean, that places the participant in an incredibly disorienting position. You're looking at an ape making a highly specific motion in, like, a virtual void.
A total void.
There are no social cues, no environmental hints, nothing but the geometry of the physical movement itself.
And from that void, the participants were required to select the correct meaning of that gesture from 4 multiple choice options.
Okay, so a 1 in 4 chance.
Exactly. Statistically speaking, if a person is just guessing blindly among 4 options, their accuracy will naturally regress to right around 25%.
Just random chance.
It would just be random chance. But those thousands of participants correctly identified the intended meanings with over 50% accuracy. It's a statistically massive leap above chance. It essentially proves that the recognition is not random guesswork. The participants possessed a pre-existing cognitive framework to interpret those signals.
They already had the software installed, so to speak.
Exactly. But the researchers went a step further to test the limits of this comprehension. They really wanted to know how much we rely on the surrounding environment to decode these signals.
Because we usually rely heavily on the environment.
Right. So they took half the participant pool and provided them with a brief 1-line textual description of what was happening in the broader environment during the video. They gave them the context.
Now, see, I would argue that context should be the deciding factor in a test like this, because in our daily human lives, context is literally everything.
Yeah.
Think about how you interpret movement based on where you're standing. If someone waves their hand dismissively at you in a crowded, incredibly noisy bar, you process the environment, and you understand that the wave means, I can't hear you, it's too loud, forget it.
You blame the noise.
Right. But if someone makes that exact same dismissive hand wave at you in a dead silent library when you lean over to whisper a question, the environment changes the meaning entirely.
Yeah, it becomes much harsher.
It carries a much sharper, almost aggressive translation of do not interrupt my reading. We rely so heavily on the situational pragmatics, the room, the noise level, the relationship, to decode both the severity and the specific intent of a physical movement.
That makes total sense.
So providing textual context to these participants should have caused their accuracy rates to just skyrocket.
That is the standard logical assumption. And it's entirely based on how human verbal communication operates. But the data from the St. Andrews study showed something entirely counterintuitive when applied to these ape gestures.
What happened?
Providing that brief textual context yielded only a marginal, statistically weak improvement in the participants' understanding.
Wait, it barely helped.
It barely moved the needle.
Yeah.
Found. It means the core meaning is not constructed by the environment. The meaning is inherently embedded in the physical gesture itself. The movement, completely stripped of its environment, still carries a robust, fixed meaning that punches right through the species barrier. The architecture of the movement itself holds the communicative power.
I don't think we should gloss over how strange that actually is.
It's very strange.
If we're saying that the physical form of the gesture itself holds the meaning, divorcing it completely from the jungle environment, divorcing it from the complex social hierarchy of a chimpanzee troop, we are suggesting something radical here. We're suggesting that a sudden flick of the wrist can still inherently mean move away to a corporate accountant sitting in a cubicle in modern-day Chicago who has never seen a wild animal.
Exactly.
It implies that the physical form of the gesture is biologically hard-coded into the entire hominid lineage. We aren't using our highly evolved human brains to deduce the meaning through clever environmental clues. Our brains are simply mechanically recognizing a physical word from a dictionary we didn't even know we owned.
And to truly grasp the weight of that biological dictionary, you have to pull these gestures out of the sterile environment of the laboratory or the computer screen and examine how they operate in the visceral reality of their natural habitat.
Out in the wild.
Yes. When you remove the safety of a multiple-choice test and watch these signals deployed in the wild, you realize the immense survival stakes attached to them.
You really have to consider what it's actually like to be on the receiving end of that raw communication. Think of a researcher, let's call him David, who spent months deep in the Budongo forest of Uganda.
A notoriously difficult environment.
Oh, absolutely brutal. You have to imagine the physical toll of that environment. You're crouching in the rotting leaf litter, your skin slick with a mixture of heavy insect repellent and humid filth. David had been tracking a chimpanzee troop for so long that he felt less like a scientist and more like a clumsy, hairless intruder.
Just completely out of his element.
Completely. The forest around him was a chaotic, overwhelming symphony of screeching sounds and moving shadows. It is a place where a sophisticated urban upbringing offers absolutely zero utility.
Well, not at all.
And then suddenly, a large male chimpanzee named Kasakia stops in his tracks. The ape turns, stares directly into David's eyes, and makes a very sharp downward motion on his own thigh.
The gesture primatologists call the big loud scratch.
Yes, the big loud scratch.
Yeah.
Now, David didn't calmly reach for his notebook to document a fascinating behavioral anomaly. It froze.
The instinct took over.
Exactly. A primitive electric fear lurched in his gut, a reaction that completely bypassed his rational academic mind entirely. He understood the command instantly. Stay back. This is my space. There was no cognitive translation required. The gesture hit him with the force of a physical blow. In that moment of intense, raw vulnerability, surrounded by the heavy smell of damp earth and primate musk, the illusion of human superiority just vanished.
All the tech doesn't matter out there.
None of it. His expensive cameras, his GPS units, his scientific methodologies, they were all rendered meaningless. The real, undeniable communication was happening in the tension of a chimpanzee's shoulder and the deliberate flick of a wrist.
Incredible.
It was a language of power, of boundaries, and a physical space that David realized he had instinctively known since before he had a name.
And, what David experienced in the undergrowth of the Budongo forest is the daily operational reality of the chimpanzee lexicon. It is not an abstract concept for them. It is literally how they manage complex societies.
It's their working language.
Exactly. Researchers who have dedicated their lives to observing these specific troops in Uganda have identified 58 distinct play gestures alone used by wild chimpanzees.
58 just for play.
Just for play. We focus heavily on play because, for primates, play is not just frivolous activity. It requires constant, high-level negotiation.
Because it can turn dangerous so quickly, right?
It requires a mutual agreement that aggressive actions like biting or tackling are not actual attacks. It requires constant reassurance.
So they have to constantly communicate their intent.
Yes. And when you analyze the specific gestures used in these negotiations, like the big loud scratch that Kasaki used to establish dominance, or an arm shake used to solicit a wrestling match, you realize they are not just random emotional bouts of animal thrashing.
They're structured.
Highly structured, intentional signals. The real breakthrough comes when you apply strict linguistic laws, the mathematical rules we use to analyze human languages, to this non-human communication.
And what happens when you do that?
When you do that, a profound, almost eerie structural similarity emerges.
Which brings us to Zipf's law of abbreviation.
Exactly. George Kingsley Zipf was a linguist who identified a universal mathematical pattern in how humans construct language.
And his law is relatively straightforward, right?
Zipf's law of abbreviation states a very simple premise. The more frequently a word is used in any given language, the shorter it tends to be.
Okay, so think about the most common words in the English language. Words like the, is, at, it. They're incredibly brief, usually just a single syllable.
Exactly. Conversely, words that describe rare, highly specific, or complex concepts are much longer. They take more time and effort to articulate. When scientists took Zipf's law and applied it to the gestural repertoire observed in the Budongo forest, they found that chimpanzee gestures follow the exact same mathematical and statistical distribution.
Really? The exact same distribution?
Yes. A highly frequent signal, something they use constantly throughout the day, like a quick stomp of the foot, is very short in duration. It executes in a fraction of a second.
Like a single syllable word.
Right. But an infrequent signal, like a drawn-out, sweeping arm shake, carries significantly more physical duration. The mathematical correlation is undeniable. Furthermore, these gestures also follow Menzelrath's law, which is another fundamental principle of linguistics.
Menzelrath's law is a bit more abstract, but it is equally crucial to this deep dive. It basically dictates that the larger a construct or sequence is, the shorter its individual constituent parts become.
Right.
Think about it in terms of human vocalization. If you use a very short word, it might consist of one long, drawn-out syllable. But if you use a massive, complex word, you naturally break it down into very short, rapid, staccato syllables to keep the overall vocalization manageable and efficient.
To compress the internal parts to support the larger structure. Analogy. And researchers discovered that when chimpanzees string multiple gestures together into a sequence, much like stringing words together into a sentence, they apply Menzelrath's law.
So they speed up the individual gestures.
Yes, the individual gestures within a long sequence are executed much more quickly and sharply than when those same gestures are used in isolation. They are actively compressing the data of their movements to build a larger communicative construct.
I find the implications of this absolutely staggering when you draw a direct analogy to how humans navigate the modern digital world. Well, Zipf's law and Menzelrath's law are essentially the governing dynamics of our own smartphone texting habits. Think about how you text.
Okay, sure.
If a friend sends you a message to confirm a lunch plan you've been discussing, you don't write back a deeply considered polysyllabic confirmation outlining your mutual agreement.
No.
You just type the letter K, or you bypass letters entirely and just tap a thumbs up emoji.
Right. It's instant.
We naturally compress our most frequent reactions into the shortest possible visual or tactile gestures because it saves time and cognitive energy. We reserve the long, drawn-out, multi-paragraph text messages for incredibly complex, rare, or emotionally fraught explanations where nuance is desperately needed.
That's a really sharp comparison.
It is mind-bending to realize that a wild chimpanzee swinging through the canopy of a Ugandan forest is utilizing the exact same data compression rules to manage its complex social life as a human teenager navigating a group chat on an iPhone.
It really speaks to a relentless, universal principle of evolutionary efficiency. I mean, any form of communication, whether it involves firing the vocal cords or moving a heavy limb, takes metabolic energy.
It burns calories.
Exactly. And evolution mercilessly prunes away energetic waste over millions of years. If an animal uses a specific signal 100 times a day, making the physical execution of that signal just a fraction of a second shorter yields a massive energy dividend over the course of a lifetime.
It's a biological optimization algorithm.
Yes. So we have this highly structured, mathematically law-abiding gestural system being used by wild apes to govern their societies, and we have the empirical, experimental proof that adult humans can instinctively understand the vocabulary of that system.
But I have to push back on that, because setting those two facts side by side reveals a glaring, almost absurd contradiction.
Yep.
If I have this ancient, hyper-efficient, mathematically optimized gestural toolkit buried deep in my DNA, and you have it in yours, why on earth aren't we actively using it? I mean, if you are sitting in a highly stressful boardroom meeting and you want an aggressive colleague to back off, why don't you instinctively do the big loud scratch on your thigh? If the meaning is universal and the energy cost is low, where did this physical language actually go in our daily human lives? Why does it feel like a dormant operating system?
To find that missing link, to see exactly where those ape gestures live in the human timeline, we have to look at humans before the dominant operating system of spoken language takes over.
Before we can talk.
Exactly. We have to examine our species before we learn to speak. We have to look at toddlers.
If adult humans are somehow suppressing or overriding these gestures, you would logically expect to see them in a raw, unedited state in human children, right before that massive software update of spoken language is fully installed and booted up.
And that is exactly what comprehensive comparative studies have documented. Researchers designed a massive observational study to look at 1 to 2-year-old human children communicating in their natural everyday environments.
Just watching them play and interact?
Yes, they wanted to see the raw data of human interaction before vocabulary fully dictated the terms. Crucially, to ensure they weren't just capturing a specific cultural quirk or a localized parenting style, they observed 2 vastly different human populations.
They needed a broad sample.
They meticulously tracked children in structured daytime nurseries in Germany, and they simultaneously tracked children interacting in their family homes and compounds in Uganda.
Looking for common ground.
Right. They cataloged every single gesture these toddlers used to demand things from their peers, to get attention from their caregivers, and to interact with their families.
I know the numbers on this, and they are genuinely staggering. When the researchers compiled the data, they cataloged 52 distinct gestures actively used in the daily repertoire of these human toddlers.
52 gestures.
Yeah. And when they cross-referenced that list with the chimpanzee vocabulary, they found that 46 of those gestures, which represents 89% of the entire toddler gestural repertoire, are actively present and utilized in the chimpanzee repertoire.
89%.
89%.
It is virtually a one-to-one physiological overlap. But what is truly significant is not just that the physical shapes of the gestures matched.
Right, it's how they use them.
Exactly. It was that the structural phases of the communication itself matched identically. Just like the chimpanzees in the Bonobo forest, these human toddlers from Germany and Uganda didn't just throw out random hand movements into the void.
They weren't just flailing.
No, they used the gestures singly. They strung them together in sequences governed by the same mathematical laws we talked about earlier.
Zipf and Menzareth.
Right. They engaged in rapid back-and-forth gestural exchanges with their playmates. And most importantly, they exhibited all the strict behavioral criteria of intentionality that primatologists use to define language in ape research.
Meaning they directed the gesture at a specific audience.
Yes. They paused and looked at the audience to wait for a response. And if their goal wasn't met, they persisted, escalated, or modified the gesture.
They are essentially running the exact same communicative software on identical hardware. We are talking about highly specific, shared, cross-species gestures here. If you watch Toddler, you will see them use the hit object ground gesture, literally slapping the floor or a table to demand immediate attention. You'll see the grab-pull gesture where they reach out and literally haul a playmate or a parent closer to them.
We've all seen a toddler do that.
Right. You see the arm raise to signal a request to be picked up, or the object shake to aggressively initiate an interaction. But what demands closer scrutiny here is how the modalities of these gestures break down.
Let's unpack the modalities.
When you categorize the toolkit, you have silent visual gestures like raising an arm. You have audible gestures like clapping hands or stomping feet. And you have contact gestures where you physically touch or pull the other person.
And both the wild chimpanzees and the human toddlers possess and utilize all three of those modalities.
They do, but the comparative data showed a very clear divergence. Human children demonstrate a significantly stronger skew toward relying on silent visual gestures compared to the chimps.
Which raises an essential debate regarding environmental influence versus biological divergence. The question the researchers had to untangle was this: is that pronounced skew towards silent visual signaling a genuine evolutionary difference?
Right. Has the human species evolved to prefer quiet visual cues?
Or is it simply a byproduct of the vastly different environmental acoustics the subjects are operating within? You really have to consider the physical space.
The environment.
Yes. A daytime nursery in Germany, or even a busy family compound in Uganda, is a fundamentally different acoustic environment than the dense, foliage-heavy, incredibly noisy canopy of a tropical forest.
Absolutely.
In a relatively quiet, enclosed room, a silent visual gesture like waving a hand or raising an arm works perfectly well. You have clear lines of sight.
But in a dense forest.
Right. In a dense forest, where the line of sight is constantly broken by broad leaves, thick branches, and shifting shadows, relying purely on a silent visual cue is a failing strategy. In that environment, an audible gesture, like a heavy stomp or a direct physical contact gesture, becomes much more reliable for transmitting a message.
I think the environmental acoustic theory makes perfect sense. You adapt the tool you are using to the environment you are currently in. But I want to push back on one specific gesture that inevitably dominates these developmental discussions, and that is pointing.
Yes.
Because humans point with their isolated index finger constantly. It feels like a uniquely, definingly human action. From a very young age, we use that index finger point to say, look at that interesting bird over there, or there's the book you were looking for.
It is a declarative action.
Exactly. It is entirely about sharing a mental state with another person, creating joint attention over a third object without necessarily demanding it. Apes do not naturally do that, do they?
Well, they do utilize pointing gestures, but the physiological form and the cognitive function are vastly different from human pointing.
So,
when a chimpanzee points, it is almost exclusively a whole hand gesture, an extension of the entire arm and palm. More importantly, the intent is strictly imperative.
It's a demand.
It is a demand. It is used to request things. The ape is saying, give me that piece of food or hand me that object. They do not use an isolated index finger point to simply share declarative interest or to provide helpful, unsolicited information to a third party.
Fascinating.
Yeah, that specific joint attention-driven declarative index finger point seems to be a heavily derived, uniquely human trait. It is a cognitive upgrade that emerges almost universally across human cultures right around 9 to 12 months of age.
So we have this massive shared evolutionary baseline, this ape repertoire that counts for 89% of a toddler's communication, plus this uniquely human index finger upgrade.
Yeah.
But again, it leads right back to the central conundrum we started with. Where do all those foundational ape gestures go when the toddler grows up? Why aren't you and I hitting the table and doing a grab pull right now?
Well, the prevailing argument in developmental linguistics is that they never actually left. They do not evaporate from our biology.
And just get buried.
Exactly. Instead, they're overridden, heavily masked, or seamlessly integrated into the incredibly complex web of adult human communication. Once a child masters spoken language, the cognitive and physical heavy lifting of communication shifts upward to the vocal cords.
The hands are suddenly freed up to do other things.
The raw, imperative ape gestures are replaced by what linguists call co-speech gestures, the rhythmic sweeping hand movements you and I use constantly to emphasize a spoken point or dictate the tempo of our speech.
Like I'm doing with my hands right now.
Exactly. Or they are replaced by culturally specific pantomime arbitrary symbols we agree upon, like giving a thumbs up to signify approval or waving a hand to say goodbye. The deep biological foundation is simply paved over by the dense infrastructure of culture and vocabulary.
Let me challenge you on the structural implications of that nature versus nurture argument, though, because the study looked at toddlers from entirely different cultural paradigms.
Yes. Germany and Uganda.
Right. On one side, you have the German toddlers. These children represent a classic weird population, an acronym used in psychology standing for Western, educated, industrialized, rich, and democratic. They are growing up in highly structured, relatively affluent, nuclear family environments.
A very specific upbringing.
And on the other side, you have the Ugandan toddlers who are growing up in larger, extended family groups with vastly different daily socialization patterns, different acoustic environments, and different cultural. If both of these groups, despite experiencing vastly different environmental nurturing from the day they are born, show the exact same 89% ape-like gestural baseline, doesn't this permanently settle the nature versus nurture debate for early communication? Doesn't it definitively prove that our first language is entirely biologically hardwired?
It settles a significant portion of the debate, but it demands nuance. You cannot simply declare victory for nature and ignore how the tools are deployed.
Okay.
What the massive cross-cultural overlap reveals is that humans possess a biological toolkit. The available physical movements, the 50 or so gestures cataloged in the repertoire, are indeed hardwired. They are the phylogenetic inheritance of the hominid lineage.
They come pre-installed.
They are in our DNA just as surely as the shape of our hands. That is the nature side of the equation. However, the tool use, how flexibly those toddlers choose to apply those movements in complex, fluid social dynamics, which specific gestures they favor to solve social problems, and how quickly they transition away from them into spoken language. That is where the true cognitive heavy lifting occurs.
Ah, so the application is nurture.
Yes, and that tool use is heavily influenced by their environment and their caregivers. The dictionary we are handed at birth is purely biological, but the poetry we write with it is dictated by culture.
Which brings us to the deepest, most fascinating cognitive layers of this entire phenomenon. Because if this ancestral toolkit, this biological dictionary, is buried deep inside our physiology, if it is just paved over by decades of spoken language, social etiquette, and cultural pantomime, what happens when it is suddenly triggered in a modern, highly socialized adult who isn't expecting it?
What the research reveals is that the old code is still running in the background. It never stops.
Imagine a researcher, let's call her Sarah, sitting in a high-tech cognitive lab. The sterile hum of server racks provides the soundtrack to her evening. Her job is to sit behind a pane of glass and meticulously analyze the instinctive physical responses of modern urbanites when they are exposed to these raw ape gestures.
Watching them take the test.
Right. On the screen, she plays a video clip of a mother chimpanzee reaching out to her infant with a very soft palm-up nudge. There's a subtle gesture. On the other side of the glass, the subject of the study, a young woman, A corporate lawyer who has spent her entire adult life navigating the rigid, artificial hierarchies of glass towers and boardrooms, watches the screen.
A person completely removed from nature.
Completely. And as the chimpanzee makes the motion, the lawyer subconsciously mirrors the gesture with her own hand. Her face, previously locked in a stoic, professional mask, suddenly softens into an expression of universal, undeniable tenderness.
Instinctual empathy.
Sarah types a note, her fingers flying across the keyboard to log the data point, but she stops when she feels a sudden, inexplicable ache in her own chest. It was the absolute roughness of the data that struck her. It was the undeniable realization of how evolution leaves jagged, unpolished edges deep within our modern, curated lives.
You try to smooth it all out with technology.
We spend our days pretending we are creatures of pure silicon and logic, operating in clean digital environments. Yet our bodies still physically hum with the ancient frequencies of the forest. Sarah realized in that moment that every correct answer recorded in her study, every instinctive recognition of an ape's intent, was a small, quiet betrayal of the Enlightenment.
Wow.
It was empirical proof that beneath our tailored suits and our glowing screens, we are still whispering to the trees, waiting for a distant relative to whisper back.
To understand the profound implications of what Sarah was witnessing in that laboratory setting, we have to forensically break down the cognitive mechanics of how human adults comprehend these signals.
How does it actually work in the brain?
Well, the online comprehension study we discussed earlier didn't just throw random primate movements at people. It categorized the gestures based on their flexibility in the wild.
Okay, so breaking them down into types.
They sharply differentiated between unambiguous gestures and ambiguous gestures. Unambiguous gestures are those that have a single, rigid, fixed meaning in the wild.
Like a word with only one definition.
Exactly. For example, the big loud scratch that David encountered. In chimpanzee society, it essentially always means groom me or submit. If a chimpanzee performs the big loud scratch, the socially expected and satisfactory outcome is that another chimpanzee will immediately approach and begin grooming them. The intent is fixed.
It's a clean binary form of communication. Action A equals demand B.
Right, but then you have the category of ambiguous gestures. These are highly flexible, multi-purpose signals that have multiple, entirely different meanings depending on the subtle social cues and the specific individuals involved.
So they require interpretation.
Heavy interpretation. The object shake, where a chimpanzee grabs a sturdy branch, a thick vine, or a sapling and shakes it repeatedly with force, is the prime example of an ambiguous gesture.
And what does it usually mean?
Well, depending entirely on the scenario and the relationship between the apes. An object shake can mean, let's have sex. It can mean, come groom me. Or it can be an aggressive demand to move away.
So the meaning of the gesture is heavily reliant on the specific, invisible social dynamic between the two apes at that exact moment in time. The physical motion is identical, but the intent is fluid.
But here is the most crucial paradigm-shifting data point from the entire adult comprehension study.
Fit me.
Out of all the gesture types tested, the object shake was the only gesture where human participants failed to guess the meaning above random chance.
Really? The only one?
The only one. They could decode the unambiguous gestures easily. They could even watch specific video clips and correctly identify the primary intended meaning of the other ambiguous gestures based on the subtle movements of the ape.
Which demonstrates an incredibly sophisticated cross-species cognitive empathy.
But the object shake completely and utterly baffled them. The data plummeted to random guessing.
I have to jump in on that data point because I firmly believe the object shake failure is the smoking gun for a massive evolutionary theory.
The location.
Because if our ability to read these ape gestures was purely based on shared general intelligence, meaning if we were just looking at an animal with an identical body plan to ours and using our advanced human logic to deduce what they were pantomiming, then a human adult, especially a highly educated one taking a test, would easily figure out the object shake. Right. If I watch a video of a massive chimpanzee shaking a heavy branch aggressively at another chimpanzee, basic human logic dictates, oh, he's displaying power, he's wielding a weapon, he clearly wants the other guy to back off.
But human logic failed to guess the correct meaning.
To me, that failure implies that the object shake relies on a highly specific, totally arbitrary cultural or biological code among the apes. It is a proprietary piece of their ancestral software that simply did not make it into the human evolutionary suitcase when our lineages split.
That is a highly astute analysis, and it perfectly frames the massive underlying mechanism debate happening in evolutionary biology right now. When scientists look at this data, they are weighing two competing evolutionary theories.
Which are?
First, is our comprehension based on a biologically inherited, hardwired dictionary? Is it a literal ancestral memory encoded directly into our neurology, passed down through phylogenetic inheritance? Or, second, do apes and humans simply share a high level of general cognitive intelligence, common social goals, and identical physiological body plans, leading both species to independently arrive at the exact same physical solutions for communication?
And the object shake failure leans heavily toward the first one.
Yes. Your point regarding the failure of the object shake strongly validates the first theory. It points directly toward these gestures being a biologically inherited repertoire rather than just an exercise in logical pantomime.
We need to clearly define phylogenetic inheritance here for the listener.
It means a physical or behavioral trait is passed down through the genetic lineage, not learned through observation. Just as you inherited the shape of your jaw from hominid ancestors, you inherited a neurological map of specific gestures. If our comprehension was based on pure logic, we would crack the code of the object shake. Because we demonstrably cannot, it strongly suggests that the mapping of that specific meaning to that specific physical movement is an arbitrary, inherited genetic link that our specific branch of the hominid family tree either lost millions of years ago or perhaps never possessed in the first place.
It is exactly like finding a word from Old English that has completely lost its meaning in modern English, even though we still actively use all the other words around it. The word is still there in the text, but the cognitive key to unlock it is gone.
Yeah.
But conversely, the fact that we can instinctively understand the fluid flexibility of the other ambiguous gestures is amazing, because we engage in that exact same fluid interpretation in human spoken language all the time.
Contextual language, yeah.
If I am talking to you and I say the word bank, you have to instantly use the context of our conversation to know if I mean the muddy edge of a river or the financial institution where I deposit my money. The word sounds identical, but the meaning shifts.
And apes are doing the exact same cognitive processing.
They're using specific physical gestures flexibly. And the fact that a modern human sitting at a laptop computer can watch a 5-second video clip of an animal they have never met and successfully identify the intended meaning of an ambiguous ape gesture.
It proves that our human brains are still aggressively wired to process that specific type of flexible, nonverbal syntax.
Right.
When you pull back and look at the totality of this research, it forces a complete foundational reevaluation of what language actually is and where it came from. We have traced a journey from thousands of everyday people playing an online game in their living rooms to the damp, screeching floors of the Bodongo forest, where wild apes execute the strict mathematical laws of primate motion.
We have analyzed toddlers in German nurseries and Ugandan family compounds who instinctively wield the exact same 50-gesture toolkit as wild chimpanzees.
And we have arrived at the profound, undeniable realization that our highly developed modern adult brains still subconsciously process and recognize this ancient ancestral code.
The overarching architecture of human communication was built millions of years before the first spoken word. The silent, rhythmic motions and subtle postural shifts deployed in modern boardrooms and living rooms are the exact same signals echoing through the African canopy. It is a biological inheritance, proving that human language is not a uniquely isolated invention, but rather an ancient, ongoing primate chorus to which we have merely added vocals.